We have number 2 we're going to work on. It says a penny is tossed and a number cube is rolled. Find the probability. Again, you always want to start thinking first about, is it independent or dependent? We discussed this. What type of events are these? Independent or dependent? Again, independent doesn't affect the first event, does not affect the second event. Whereas dependent, the first event, the outcome of that affects the second event. So what did we decide for this one? Yeah. Independent. Yep, they're two separate things. So I want to know the probability of flipping a heads, and I want to know the probability of a dice rolling an odd number. Okay, so how many outcomes are there for a coin? How many different outcomes could you have?
Two.
Two. And then how many heads are on a coin?
One.
Yeah, so you have a 1 in 2 chance of flipping a heads. All right, next. We want to know what is the probability of rolling an odd number on like a dice. First off, how many total outcomes are on a dice?
6.
6. How many numbers on your dice are odd?
3.
3. Students will say, should I reduce? You can either reduce right now or you can reduce at the end. So if I want to right now, divide both by 3 and I get 1/2. To solve the probability of both events happening, you take the probability of your first event and your second event and multiply. So 1/2 times 1/2 will equal, you multiply straight across and you get 1/4. So my answer is capital P equals 1/4. So the probability of flipping a heads and rolling an odd is 1/4. I have a 1 in 4 chance of that actually happening. Next, number 3, it says cards labeled 5, 6, 7, 8, and 9 are in a stack. A card is drawn and not replaced. That is a key part. The fact that it's not replaced makes it what? Yes? Dependent, meaning it's going to affect the second one's event. Find the probability of drawing 2 even numbers. So we're going to say the probability of an even number, whoops, and this is for your first event. Then we're going to do the probability of an even number for your second event. Now, how many total numbers or cards were there? Yes? 5. How many even numbers were in that 5? 2. So we have a 2 in 5 chance. The thing that changes now is if I were to have drawn this 6, it is no longer there. So how many outcomes do I have left now? 4. And we're assuming that we drew a 6, an even number. How many even numbers are left? Yes, 1. All right. So therefore, we take the 2 probabilities, 2/5 and 1/4. I'm going to do some cross simplifying. And I get 1/10. So my answer is capital P equals 1/10. I have a 1 in 10 chance of drawing an even number for both. All right.